I created an entire short film in under 10 minutes using nothing but AI agents and automation. So no expensive software, no film crew, no months of production time. What you're seeing right here would have cost thousands of dollars and taken weeks to produce just 2 years ago. But I'm about to show you how to create Hollywood quality short films in minutes, not months. Now here's what most people don't realize, because while everyone is manually jumping between ChatGPT, Leonardo AI, and Runway, there's a way to connect all of these tools together so that they work automatically for you. One click and your entire movie pipeline just runs itself. But here's the problem most creators face. They spend hours copying and pasting between different AI tools, losing consistency in their characters, and then burning through credits faster than they can actually afford. So that by the end of this video, you are going to have a complete automated system that takes a single story idea and then transforms it into a finished short film with consistent characters, professional animations, and synchronized sound effects. And the best part, once you set it all up, you can create unlimited movies with just one click. So let's go ahead and dive in. And I added the AI tools that we're going to use today in the description below so that you should go ahead and check them out too. All right, so most people think that creating a full set of videos means hours of manual work, but with the right setup, it only takes a few minutes. In this demo, I'm gonna show you exactly how raw ideas turn into finished production-ready videos with nothing more than ChatGPT, Google Sheets, and an n8n workflow. Now, this is how the workflow works end to end. And later on, I'm gonna break down the exact build so that you too can set this up for yourself. I'll start in ChatGPT, where I'm going to ask it, of course, to generate a table with all the inputs the workflow needs, and that's titles, ideas, captions, and video URLs. As soon as the table is ready, I will paste it straight into Google Sheets, and I'm gonna mark each row as for production. Now that's the signal that these entries are live and ready to be picked up. And then from there, I'm gonna jump into n8n here, open the workflow, and hit execute. And instantly, as you can see, the data from the sheet flows in, and row by row, it's processed into complete videos. That's captions, media, and outputs that are all mapped automatically while the workflow runs in real time, so that when execution finishes, the results are already waiting. Every video is generated correctly, the captions line up with the content, and the outputs are stored in Google Drive and WebView. Now, what normally would have taken hours is now a smooth end-to-end process that runs in under 5 minutes. All right, so now that you've seen the full demo run from start to finish, it's time to break down how the workflow is actually built. We'll go step by step, starting with the trigger that makes everything run automatically without us lifting much of a finger. Now, the first step is making sure that this workflow runs on its own. We don't want to rely on manually pressing execute every single time, right? We'll add an on-schedule trigger node to handle all of that. This is what makes the workflow start at a set time automatically. So we'll configure it to run daily, setting the interval to 1 day and the time to exactly midnight with the minutes at 0. And that way, every new day starts fresh with an automated run. And if there's ever a need to adjust the timing, the schedule can be changed easily, but for now, midnight keeps it consistent. So once that's in place, we will execute the step just to confirm that the schedule works. From then on, the workflow will launch automatically at the time that we set, giving us a reliable foundation for everything else that follows next. The trigger is ready, but a schedule really alone doesn't mean much unless the workflow knows what to work on. So every run needs a clear set of inputs. That's ideas, captions, and styles that define the content. I don't want to leave that scattered across notes or documents. So we are going to centralize everything here in our Google Sheets. Now this will serve as the database that the workflow pulls from. So we're making sure that each run starts with structured production-ready topics. And I'll start that by adding a Google Sheets node here, and we will connect it to the sheet where all of our topics will live. The operation is set to get rows, and the resource is sheet within document. And from there, I'll just pick the document that will define the source document containing our topic table, and then select sheet 1, which holds the table itself. To make sure the data is clean, we'll prepare it first. So inside of ChatGPT, I'll generate a table with columns for ID, idea, caption, channel style prompt, character style prompt, production status, final output, publishing status, and error log. Every entry gets marked for production under production status, while final output, publishing status, and error log stay blank. So once that's ready, I'm going to copy it straight into the Google Sheet, and then back here in n8n, I'm going to add a filter to the node. This checks the publishing status column and only pulls rows marked for production. I'm also going to toggle on the option to return only the first matching row so that each execution processes one topic at a time. After running the step, the workflow grabs the active row from our Google Sheets. Right now, the system knows exactly which topic to work on, and everything is structured in a way so that the next stages can build on it without any errors. Having a topic pulled from the sheet is just the first starting point. The real value comes when that topic is expanded into a full trailer concept, a sequence of scenes that defines the story, the visuals, and the characters. The AI agent takes over at this stage, transforming the structured input into a polished storyboard that reads like it was crafted by a professional creative team. I'll start by adding an AI agent node here, then I will change the source for the user message to define below to give full control of the input instructions. Now I'm going to start preparing a user message using ChatGPT that feeds in all the essentials: the topic idea, the visual style of the clips, the character description, and how long each moment should last. So that message gets dropped directly into n8n here so that the system has clear instructions to follow next. To keep the output tight, I'll toggle require specific format on so the output stays structured and predictable. After that, I'm going to add a system message. I'll generate the prompt in ChatGPT, and then I'm just going to copy it over and then paste it back into n8n. That way, the AI follows the right behavior and tone every single time. So now let's go back to Canvas, then add a chat model. I'll use Gemini Flash here. Inside the output tool, we will add a structured output parser. In order to set it up, I'll generate a sample JSON schema in ChatGPT. I'm going to copy and then paste it back into n8n. This makes sure the AI's response comes back in clean, structured data that the workflow can use later on. I'll execute the workflow to let the AI agent generate the trailer scenes. Now, if it doesn't work the first time, we can just run it again until it succeeds. And once the output is ready, I'll rename the node to movie trailer scenes so everything stays organized. Lastly, we need to pin the data, which locks the results in place and then makes them reusable without us having to rerun the agent each time. Now that the AI agent has generated the full storyboard for us, the next step is to break it down so that our workflow can actually work with it. Having everything bundled in one big block might look neat, but it does make it impossible to process each scene on its own. So to fix that, I'm going to split the output into individual items so that every scene becomes a separate entry in the workflow. And I'll start by dragging in a split out node here. This is what divides the structured output into manageable pieces so that n8n can loop over one by one. And once the node is in place, I'm going to grab the output field coming directly from the AI agent. That's where all the trailer scenes are stored, and it becomes the source for this step. So after wiring that in, I'm going to run the node. As soon as it executes, the big block of scenes is broken apart into smaller items, each representing a single scene. Now, this makes the workflow much more flexible because then every scene can now be processed separately, whether that's adding visuals or building audio or mapping it into later steps. So each trailer scene has now been split into its own item, which means the next move is to turn those ideas into cinematic clips. So for this step, I am going to connect the workflow to Pi API's VO3 text-to-video model so that every scene prompt and duration from the last node transforms directly into a video file inside of n8n. I'll start by adding an HTTP request node here and switching the method to post since we are sending data to create new video tasks. Over here in PyAPI under Video Models, then VO3, I'm going to click Run API to open the dev page, copy the text-to-video endpoint URL, and then paste it right into the URL field inside n8n. Now that sets the target for where each request needs to go. For authentication, I'm going to toggle Send Headers On, create a header called XAPI key, and then paste in my PyAPI key from the PyAPI.ai dashboard. After that, I'm going to toggle Send Body On, set it to JSON, and then prepare the request body. Using ChatGPT, I'll generate the JSON code that includes both the prompt and the duration pulled from the previous node, and then I'm going to paste it into n8n so that every request is properly structured. Since multiple scenes might be processed back to back, I'm going to add some batching controls. Concurrency is set to 1 with an interval of 10,000 ms, which prevents overwhelming the API by spacing out requests. With that in place, I can execute the step now and let PyAPI start generating videos for each trailer scene. Now I need to rename the node to generate videos just for clarity and pin the response data. So that way, every generated clip is stored and it's ready for the next stage of the workflow without having to rerun the call. Now, after sending the prompts to PyAPI, our workflow does need a way to actually collect all the finished outputs. Each video scene is tied to a unique task ID, and that's what we'll use to fetch the final results. Now, this step makes sure the generated clips are pulled back into n8n as direct URLs ready for storage or downstream processing. I'll duplicate the Generate Videos node here so that all the PyAPI configuration is already in place. We will change the method to get since the call is about retrieving results instead of creating new tasks. Now here in the URL field, I'll click expression, add a / at the end, and then map in the task ID from the input. And that way the request points directly at the exact video job created earlier. Because getRequests don't send data, I'll toggle Send Body off and then clean up the setup by deleting the batching options, as this does prevent unnecessary API throttling since this is just a single retrieval. After that, I'll execute the step and watch as PyAPI returns the completed video to me. As per usual, we need to keep things clear, so I'm just going to rename the node to Get Videos and then I'm going to pin the output. Doing that locks in the video URL so that they can be reused in later steps without repeatedly hitting the API. After the individual video clips are retrieved, the workflow needs to bring them all together into a single structured dataset. Handling them separately makes later steps a little bit messy, but consolidating everything into one list keeps the whole process clean and easy to work with. This aggregation becomes the foundation, storing for reviewing or even publishing the videos in bulk. I'm going to add an aggregate node here and then set the mode to all item data into a single list. This configuration tells n8n to bundle every video result into one structured output instead of scattering them across multiple branches. After executing the step, the workflow generates a single dataset containing all the video URLs and the related metadata. And from here, every video clip can be managed as part of one consolidated package, which makes the next stages much more efficient. At this point, the workflow has generated multiple videos, but they won't all be in the same state. Some will already be complete, others may still be processing, and a few could return some errors. So to manage these different kinds of outcomes, I'm going to add a switch node here, which lets the workflow route execution based on the status of each video. For the first routing rule, I'll set it to completed, so whenever all videos do finish successfully, the workflow moves down that path. In value 1, I'll drag in the status field expression shown here on your screen. The condition is set to is equal to, and in value 2, I'll type completed, completed, completed. And after that, I'll toggle on rename output and change the label to completed. This makes sure the workflow only routes forward when every single video has finished successfully. Next is the rule for pending videos. I'll use the same status expression, again visible here on your screen, but we'll adjust the condition so that it catches any video that's still marked as pending. This guarantees that partially finished runs don't slip through and that the workflow can wait or loop back until everything is ready. The output here will be renamed as pending. Finally, I'll set up a third rule to handle all the errors. So for this one, the condition looks for any failed messages using the expression that you see here on your screen. So if a video task fails, the workflow routes into a dedicated error branch, giving me space to log the problem or trigger a retry. And of course, to keep everything clear, I'll rename this output to error. And after setting up all the 3 paths, completed, pending, and error, I'll execute the step. The workflow now sorts videos into the right branch automatically, giving me a clean and reliable way to handle every possible status. After splitting video statuses into completed, pending, and error, the workflow now needs to handle the last 2 branches. Pending videos shouldn't be marked complete too early, and of course, errors need to be logged properly so that nothing slips through unnoticed. This step sets up the logic that keeps the process reliable even when things don't go perfectly as planned. So for the pending path, I'll add a wait node here, and then I'm going to set it to 5 seconds. This short pause gives PyAPI more time to finish generating videos before the workflow checks again. Once the wait is over, the node reconnects to the get video step, creating a loop that just keeps cycling until the videos are actually marked as ready. Meanwhile, while all that's happening, we're also going to configure the error path by duplicating the Google Sheets node here that we used to pull topic data earlier. Now this time, I'm going to switch the method to update row since I am writing back into the sheet instead of just reading from it. In the configuration here, I'm going to map the ID from the getRows node so that the update targets the correct entry. For the fields, I'll set production status to error and fill the error log with the note failed to request on VO3. This way, errors are documented directly in the sheet where everything else is tracked, making them easy to debug later. Now, once both branches are in place, I'm going to execute the workflow. Pending tasks now wait and then retry automatically, while failures are logged back into Google Sheets for my review. And that closes the loop on error handling and keeping the workflow self-correcting. Okay, so our workflow already has videos lined up. So the next step is to pass that data into JSON to video for rendering. And to do that, we're going to bridge n8n with the external service using a straightforward HTTP request. I'm going to add an HTTP request node here and then set the method to post, since this step involves sending instructions rather than retrieving information. The base URL for JSON to video is shown here on your screen. And I'm going to copy that from their tutorial page and then paste it directly into the URL field in n8n so that our workflow knows where to deliver the payload. Next up, let's go ahead and handle authentication. Inside the header section here, I'm going to create a field called XAPI key and paste in the API key from my JSON to video account. This ensures the request is tied to my account and accepted by the API. So let's go ahead and wrap things up. I'm going to toggle on send body so the node is ready to send video generation instructions. And with that part enabled, the request is fully prepared and is now waiting for the structured data that will be added in the next step. And so far, we've got the HTTP request ready, but before the workflow can send anything meaningful, I do need a template inside JSON to video that defines the structure. This template will act as the stage where all the video clips and captions will be placed so that when n8n runs, it just fills in the blanks. I'm going to open JSON to video and create a brand new template here. Inside the template, I'll start with scene 1, add a new element, choosing video as the type. Now this sets up the container where the generated clips will appear. And then from here, I will click the pen icon, grab one of the links from the Get Videos node back in n8n, and then paste it into the video URL field as a placeholder. After hitting enter and saving, the template now knows how to handle a video slot. Now we need to make sure the sizing is correct, so we will also reload the page before adding any more elements. Next, I'm going to add a text element into the same scene. Here, I'm going to configure the font, the size, and position so captions or overlays display exactly where they should. I'm also going to adjust video playback settings like fade-ins or fade-outs to give the scene a bit more of a polished look. And once that's done, I'm going to duplicate this setup 5 more times, giving me a total of 6 scenes to work with. Now lastly, I'm just going to head over to the JSON editor at the top of the screen, then under template. Now on your screen, you're going to see how the static placeholders are swapped out for dynamic ones that n8n can populate later. Now after saving those changes, the template is fully set up to receive inputs now, so that from this point on, n8n will inject the videos and text automatically, and then JSON to video will render everything according to the structure that we just built. Right now, the JSON to video template is ready, and the workflow needs to pass in the actual videos and the actual caption. So I'm going to open the same HTTP request node that we set up earlier, and I'm going to scroll down here to the JSON body section. This is where the dynamic variables are mapped into the template. Here on your screen, you'll see the prepared JSON structure that includes the template ID, the video slots, and the text slots. Each video placeholder is tied to an output from the Get Videos node, and each text placeholder is mapped from the captions generated in the movie trailer scene step. Now here's a quick tip for you. If no clip exists for a scene, you can upload a 1-second black screen video to JSON to video and then use that as a fallback. So that way, scenes 4 and 5 always have something in place instead of just breaking up the whole sequence. Next, all I need to do here is replace the template ID with the one from the JSON to video editor, making sure that each video slot points to the right output from the Get Videos node, and then lines up the text placeholders with captions from the movie trailer scenes node. This ensures that every video and caption pair stays matched correctly. And once everything is set up, I'll execute the step now. JSON to video picks up the mapped values and starts rendering the full video with the placeholders filled in. And after it runs successfully, I'm going to pin the data again so that downstream nodes can always access the generated URLs without rerunning this step. After sending the request to create a movie in JSON to video, the workflow needs a way to know when that rendering is finished. So I'm going to duplicate this create movie trailer node so that we can track the status without changing the original request. Inside the duplicated node, I'm going to switch the method from post to get, since again, this step isn't about creating anything new. Get is the right choice for checking the progress of an existing render. On your screen here, you'll see the status URL from the JSON to video docs. I'm going to paste that into the URL field, and then I'm going to open the expression editor here and then map in the project ID from the create movie trailer node. And that way, the workflow always queries the correct render instead of a static placeholder. Because this is a GET request, I'm also going to make sure the send body is turned off. Once everything looks set, I can now execute this step. And JSON to video responds with the current status of the movie, whether it's still rendering or is already complete. And from here, our workflow can now decide when to move forward, ensuring it only continues once the finished video is actually ready. After checking the movie status, the workflow needs a way to pause until the rendering is actually finished, right? So I'm going to add an if node here to the canvas and configure it so that it compares the movie status against the word done. If the status matches, the workflow continues down the true path, which means the render is complete. Now, if the status doesn't match, that's where I'll set up a loop. Here in the false branch, I'm going to drop in a wait node, and I'm going to set the delay to 5 seconds so that after that short pause, the workflow can connect back to the get movie status node and then runs the check again. And this creates a simple polling loop that keeps asking for the status until JSON to video reports back that the movie is done. With this loop in place, the workflow won't jump ahead too early. It'll just wait there gracefully, checking every few seconds and only moving forward once the finished video is actually ready. Once the rendering is marked as finished, the workflow needs to actually pull down the final video. So I'm going to add a new HTTP request node here and then set the method to get, since again, we're only retrieving information here in this part. In the URL field, I'm going to map in the link coming from the get movie status node. And that way, the request always points directly to the completed project instead of requiring a static link. Because it is a GET request, there's no need to send any body data. And just like in other sections, we need to keep everything clear, so that we'll rename this node to download video. After executing the step, JSON to video responds back with the finished movie's URL along with any related metadata. This means that the video is now ready to be used in the next steps of our workflow. Given that the final movie is ready, the next step is to store it somewhere accessible so that every generated video is saved and then is also easy to retrieve later. I'm going to add a Google Drive node here to our canvas and then set the operation to upload file. For the file name, I'll map in the idea field from the topics node. That way, each video gets saved with a descriptive title that matches the project instead of just some generic file name. Next, I'm going to choose the drive account where the file should live and select the specific folder. So, for example, a movie trailers folder inside my drive. Now, once those details are set, I'll just execute the step and the completed movie is uploaded into that folder automatically, creating a clean record of everything that our workflow produces. Once our movie has been uploaded, the workflow also needs to be able to log a record of it so nothing slips through the cracks. So I'm going to duplicate the existing error log node here and then repurpose it for successful runs. And that way we'll have one node for failures and another for completed outputs. Inside the duplicated node here, I'm going to set the production status to done so it's clear the render finished successfully. For the final output field, I'll map in the web view link from the completed video, and that gives us a direct path to the video every time. I'll also update the publishing status for publishing, marking it as ready to move into distribution or scheduling steps. After executing the node, the log now contains a complete entry: production marked as done, a working video link saved, and the publishing flag set correctly. Doing this creates a reliable record of every finished movie so that our workflow stays transparent and is easy to track. And there you go, another workflow for you in your toolbox. And yes, this is how you can create a full movie in minutes with just AI agents. So stick around because we're only really scratching the surface of what's possible here. Subscribe, I'll see you in the next one, and thank you for investing your time with me today.